So 54x and then plus 30y equals 72. We're dealing with big numbers, so don't be afraid to use your calculator while you're doing some of these. And then I'm going to take e and multiply everything by a -5. So I'll have negative 25x minus 30y, those are the ones that are going to cancel, equals, and I will have negative 130. All right, so when we combine everything up, I subtract 54 minus 25, I will get 29x. These will cancel, equals, and then I get negative 58. Again, don't be shy about that calculator. These numbers are getting big. So to get x by itself, divide both sides by 29. So I end up with x equals negative 2. That's my first value. All right, and then I am going to plug this in to either of these equations. I could do one of these too. I'd just rather avoid the big numbers. So maybe we plug it in to D. So 9 and then plug in negative 2 for x. Plus 5y equals 12, and now we can solve for y. So this is going to be a negative 18, so I'll move it by adding 18. Okay, that'll cancel. I get 5y equals 30. Divide both sides by 5 to get the y by itself. And so I get y equals 6. So that's my second variable. And then I'm just going to sneak in a step 3 here. Step 3 is to find the last variable. So we've got 2 for 3. Finding the first one is the hardest. Finding the second one is really quick. And then we're just going to plug in what we have, these two, into any of these original equations so that we can solve for z. So maybe you always want the first, or like the one with the lowest coefficients, whatever. So let's go with this one just because the z only has a negative 1 in front. So 2x becomes 2 times negative 2 plus y, so plus 6, minus z equals 5. And that's the last thing to solve for, so we can get that by itself. So this is negative 4 plus 6, so that's 2. I'm going to subtract 2 from both sides. So I get negative z equals 3. So if I divide both sides by a negative 1, I get z equals negative 3. And so, oops, there we go. When you're listing your ordered triple, it's ordered for a reason. You want the x first, then the y, and then the z. So that is the one point in the coordinate system where all three of the planes overlap each other. All right, so now we are going to move to this next example here. Sorry, my video messed me up. Example 2, okay, solve each system of equations. So same 3 rounds. We're going to do 2 rounds of elimination. So let's go with, let's get the y's, because this has a single y right here, and we can just easily multiply to get these two to cancel. So this is A, B, and C, really good way to keep yourself organized. So if we combine A and B, this is a 2y, so this one's good already. We're going to multiply this by a negative 2 so I can get opposite y's. Okay, so B is perfect, just the way it is, no changes necessary. And then I'm going to multiply everything in A by a negative 2. So negative 4x, negative 2y, positive 6z equals negative 10. Okay, so get those, combine these up. Those will cancel. I get a negative 3x. I'll get a positive 2z equals negative 3, and I'm going to call that D. I'm going to come back for that guy later in step 2. All right, round 2 of elimination. Now I have to use C because I haven't used it yet. So this is a positive 3y. I can make this a negative 3y. Remember, in this step, you always have to eliminate the same variable. It won't do you any good if you eliminate 2 different variables in these 2 rounds. So C is good, just the way it is. Okay, and I'm going to multiply everything here by a negative 3. So negative 6x, negative 3y, positive 9z equals negative 15. Now, you may notice the way that this is lined up. Absolutely everything here is going to end up canceling. So what I come up with is 0 equals 0. There are no variables left. Remember what we did in that previous section? Or actually, it was 3-1. If you get a true statement at the end like that, what that means is that there are infinitely many solutions. So it could be that they all intersect in a line. It could be that they're all the same plane. We've got a couple of options there, but really the only important part is that you're not going to be able to find a single solution that works. There are an infinite number of solutions. All right, next, this will be the last one for this video, and then video 2 will be very short. So this, we are going to do the same 3 steps. We're going to label these A, B, and C. Okay, and then it looks like, again, the y is probably going to be easiest to eliminate. because you don't have to multiply by anything crazy. Always look for something that's by itself because it's easiest to manipulate. So in round 1, this is a negative y. So if we could get this to be a positive 2y, it'll cancel with this negative 2y. So let's take a and multiply it by a negative 2, and then leave b just the way it is. Okay, so multiply everything here by a negative 2. I'll have negative 6x, positive 2y, positive 4z equals negative 8. And I will line b right up underneath it. Okay, and I'm hoping you're seeing what's happening here. If you look on the left-hand side, all the variables are going to cancel. So we get a 0. And then on the right, we get a 3, which 0 obviously does not equal 3. That's a false statement. And so when you're dealing with a false statement, what you do is you say that there is no solution. Okay, so part A and B are similar. You don't end up with one unique solution, but you can either say there's infinitely many or you can say that there is no solution. All right, so that's the end for this first part.